Now we examined in the previous example up before how two lines can intersect each other. And we found out that they can intersect each other at one point, at no points, or infinitely many points. Now we looked at it in terms of a graph. Now we want to look at it in terms of just the pure algebra of it. So we want to forget about any graphing, just use that as kind of a motivation for our intuition. And we want to see what happens when we just look at the algebraic solutions. So let's take the first system of equations. Now we remember this had one point of intersection. And in fact, if we solve this, so I'm going to solve this by substitution. And what I'm going to do is I'm going to replace the y in the second equation with 2x minus 1 from the first equation. Negative x plus 2. And if I solve for this, I end up with 3x equals 3, which means that x equals 1. And the y value is going to be, I'll do it quickly, 1 as well. So the point of intersection in this case is 1, 1, which confirms what we did in the graph above, in the previous example. Now let's look at where it starts to get interesting. Here was the system of equations that had no solution. And let's see what happens algebraically when we try to solve it. So I'm going to solve by elimination by making the first equation have a coefficient of 4 in front of the x because I want it to match up with this 4x here. So I multiply that first equation by 2, everything. So it'll be 4x plus 6y equals 12. Sorry, not 12, 24. So 20... No, not 24, it is 12. What am I saying? Is 12. In this equation, I'm going to keep the same. So it's just 4x plus 6y equals 24. So to eliminate the x, I'm going to subtract the two equations together. So the 4x and the 4x cancel each other out. 6y and 6y also cancel each other out. So what I have left on the left-hand side is just a big fat 0. And 12 minus 24 gives me negative 12. In other words, based on this, 0 is equal to negative 12. And that's where you should stop and say, hey, something is up because 0 is certainly not equal to 12. And this is a result of what happens, of when you have two linear systems that don't intersect. When you try to solve them, you're going to get what is known as a contradiction. Something absurd in mathematics, such as 0 equals 12. You might get 3 equals 5, 0 equals 7, anything like that which makes no sense mathematically, at least not in this universe. So that's what happens when you try to solve a system that has no solutions. On the other hand, when you try to solve a system that has infinitely many solutions, here's what I'm going to do. I'm going to keep this first equation, y equals 5x plus 1. Let me zoom in a bit. And the second equation, if you recall, when we isolated for y, we got the same thing, y equals 5x plus 1. Now, to make it a little bit more recognizable, I'm just going to rewrite the equations with the x and y's on one side. And notice that we get the same thing. So if I try to eliminate, in quotes, a variable, let's say I try to eliminate the 5x, that means I subtract the equations from each other. What happens is the 5x minus 5x becomes 0. The negative y minus negative y becomes 0. So 0 plus 0, negative 1 minus negative 1 becomes 0. Zeros everywhere. I just get 0 equals 0, which is obvious. So it's the exact opposite of the previous scenario where we had 0 equals 12. In this case, we get an identity. We get a number equaling itself, and whenever we get something like that, it just means there are infinitely many solutions. So we've seen here the three cases and what happens when we try to solve. The most interesting one, and the one we'll be looking at the most, is this one here. But you do have to know algebraically what it means when you try to solve and get a contradiction or an equality, an identity.